Hello friends and welcome to Parabola part 2. So in the previous part we have discussed what parabola is. And so in this part we're going to discuss some important terms related to parabola. So without wasting any time, let's get started. So in the previous lecture we have seen what parabola is. Parabola is any conic section which had SP is equal to PN. So what are the important terms related to it? As we have discussed in the conic section general lecture that we have 5 to 6 important terms like axis, vertex, lattice rectum, double ordinate and etc. etc. So similarly for a specific conic section we are going to discuss the same. So the first term which is coming up is axis. Axis, as we know, is any straight line which passes through the focus and is perpendicular to the directrix. Or we can say SZ is the axis of the parabola. Now, which is this parabola? In the previous lecture, we have seen that we have proved a standard equation of parabola which was y square is equal to 4ax. So, the important terms which we are talking about is for the y square is equal to 4ax parabola. So the first term is axis and we have seen that axis is SZ. Let us recall what we have discussed. We have seen that this was y-axis and this was x-axis. So the axis of the parabola y square is equal to 4ax was or is x-axis. So axis is x-axis. So the next term is vertex. Now what is vertex? The intersection of the conic section with the axis is vertex. So did you see the A? Yes, the A is the vertex of the given parabola. Now just assume y-axis and x-axis intersecting at a point A, and in the previous lecture we have also seen that this intersection was at the point 0, 0, or we can say the vertex is A and which is the origin of the given parabola. So we have seen what vertex is of the parabola y square is equal to 4ax. So the next point is, or the next term is focal chord. Now focal chord is any chord which passes through the focus of the given conic section. The purple line segment which you see on the right side is the given focal chord. So I'll just name this point F and F dash, and so F dash is the focal chord of the given parabola as it passes through the focus S. So the next term is double ordinate. The green color line which you can see is the double ordinate. Double ordinate is any such line segment which is perpendicular to the axis and it touches the given conic section at 2 points. So double ordinate, I just name this as Q and Q dash. Q comma Q dash is the given double ordinate of the parabola y square is equal to 4ax. So what we're going to do is we're going to find the coordinates, and so mathematics will be involved in it. So finding such coordinates, how should we proceed? The simple way is we're going to take this point as h comma 0. Now you may be wondering why h comma 0. See, as we have seen that axis is x-axis, so any ordinate would be 0. So let us assume the x coordinate as h. So since x coordinate is h, q and q dash will also have the x coordinate as h, as it is the perpendicular line to the axis. So what is the coordinate? Since q and q dash is a point on the parabola, so the point h will satisfy the given curve. And so if h satisfies the given curve, so y will be equal to plus and minus 2 root ah. And so the y coordinate of q and q dash will be 2 root ah and minus 2 root ah respectively. As we can see, q is to the positive side of y-axis and q dash is to the negative side of y-axis. So the coordinates of q is h comma 2 root ah, and for q dash it is h comma minus 2 root ah. So let's move on to other terms. So the next term coming up is lattice rectum. As you can see the green color line over here which passes through the focus S, lattice rectum is a double ordinate which passes through the focus. So what we're going to do is we're going to name L and L dash, and similarly as we have found out the double ordinate, the coordinates for the double ordinate, we're going to do the same over here. But let's move on to the previous lecture. The previous lecture proved something, that AZ is equal to AS, and so we found out that S has the coordinates a comma 0. So since S has the coordinates a comma 0, then L will also have the x coordinate as a. And since the x coordinate as a and this curve being y square is equal to 4ax, a will satisfy the given equation. And so y square will be equal to 4a square. So y will be equal to plus or minus 2a. So we'll get a comma 2a and a comma minus 2a as the coordinates of L and L dash respectively. So the term lattice rectum L dash has L coordinate as a comma 2a and L dash as a comma minus 2a. So guys, can you think of the length of the lattice rectum? Yes, 2a plus 2a, which is equal to 4a, is the given length of the double ordinate. And so just think of this 4a over here. Can you relate something? What I can relate is any y coordinate, then length of L dash multiplied by x coordinate. What will you get? The equation of the parabola. This thing you have to remember, guys, because some or the other question you will directly get the length of the parabola, the length of the lattice rectum of the parabola, and you will be asked to get the equation of it. And if you have the length of the parabola, you can directly find the equation by either getting any y and any x and directly putting into this equation. So what you need to remember over here is this part. This is something important and we're going to surely do a question based on it. So let's move on to the next term, and the next term is focal distance. As you can see, focal distance is any distance or any length of the chord which passes through the focus. So SP, as you can see, is the length of a chord passing through the focus, and so SP is the focal distance. Now how do we find SP? As SP is not a perpendicular distance, so we don't know the x coordinate or any y coordinate of P. So how do we find it? Again, recall the first lecture, and the first lecture said that SP is equal to PM for any given parabola. And so the length of SP will be equal to PM. And how do we find PM? We find with the perpendicular distance formula. Since the directrix of the given parabola is x is equal to minus a, or we can say x plus a is equal to 0, putting the point P, x comma y into this equation, we'll get x plus a upon root under 1 square mod will be equal to SP. So since we got SP, SP will be finally equal to x plus a. So if you know the coordinate, any coordinate at P or any coordinate of P like the x coordinate, you can easily find out the focal distance with directly putting this equation. So next move on to our last and final term of this topic, and that is parametric coordinates. Now what do this mean? As we have discussed in the circle theory also, parametric coordinates are any coordinates which satisfies the given curve or the given conic section. So if we assume any point x comma y, any point x comma y over here, any point x comma y over here, assuming x comma y will not give us something. We want something. So parametric coordinates, how do we find them? What we can do is, we know the formula y square is equal to 4ax of the parabola. So what we're going to do is, we'll take y, we'll take 2a over here, divide by 2a. So what we are remained with? We are remained with 2x upon y. And what we're going to do is, we're going to equate this to a random variable t. So equating this to a random variable t, what we get is y as 2at and x as at square. You can solve this. So parametric coordinates of any parabola of the form y square is equal to 4ax is at square comma 2at. Guys, parametric coordinates is very useful in solving any type of question related to any conic section. So you must remember all the parametric coordinates of all the given conic section. So we end up over here with the parametric coordinates and the important terms related to the conic section parabola. So guys, this was it from this lecture. I hope you enjoyed it. You got to learn many more things. So thank you guys. This is Yojit Bhasin signing off. See you in Parabola Part 3.